I'm going to ask Dr. Dasgupta to start his presentation. Again, thank you, and you're looking great as usual. We cannot hear you.
So you can see your screen. I'll let you know when I can see your presentation.
Can you hear me now? Can you hear me?
Yes.
Okay. Okay, let's see. Okay. Yeah. How about now? Is my screen visible?
We can see and hear your presentation. You might want to just go full screen. It's up to you.
I think I'm in full screen. Am I not?
Why not?
Kishore, are you there? Can you see the screen or no? That's the point.
Yes, yes, we can. We can see your screen.
So should I go ahead then?
Yes, please. Yes, please.
Okay, so you can see this is what my plan is to present today. I'll talk about AI methodologies, my research on AI ML, and then the concept that since 1995, I'm pushing for how to build digital immunity. And so I mostly work on the AI in cybersecurity, but my interest also across any different discipline. So then I'll move to AI-based authentication that last 7-8 years we significantly invested our effort since 2008 or 9 in different problem solving in authentication until recently. And they were well-funded research and other things you can see. And on that same venue, I'll finish with how on the field of authentication, where we are heading. So that's my agenda for the day. Hopefully, if things work out, I'll be able to finish it. Now, let's see. So when I see, Stacy, you mentioned that you don't see my full screen. Is this still the issue?
No, everyone can see you, sir. Go right ahead.
So when I see AI/ML, there are at least 50 different algorithms plus their derivatives and many heuristics that I believe constitutes AI/ML techniques. Now, to me, when I see large-scale explosion of using AI in many fields, which is good, but I would like to give this message that AI is not magic, it is computational logic. There are many mathematics and statistics behind all those algorithms that we call computational algorithms. And if you look at fine-grained details, AI is not equal to ML. If I take the superset, the algorithm and which composed of AI composed ML is part of AI, and then you can many branch you can do it. Artificial neural network, deep neural network, CNN. This is one branch. Then another branch can be all different heuristics, and then guided search. All this part of this AI ML domain. And in old days, we used to call it connectionist and symbolic. So there are many ways we label them as AI, symbolic AI or non-symbolic AI. Now, some AI techniques are model-based, some are data-driven. Actually, majority of those are data-driven, and they rely on the data quantity, quality, and reliability, whether they are noisy or noise-free, variations. So those are fundamentals. And if you look at the learning models, supervised, unsupervised, semi-supervised, reinforcement, real-time, incremental, etc. So many different variations. But important thing is all models require parameter tuning for effectively use as decision support to perform detection, recognition, classification, prediction tasks. So performance typically varies on two focus areas. Do you want to build a generalized model or specialized model? If you want to make a specialized, then it can only do the specific things. Any variation, it may not work. If you make it too generalized, then it can not be a good classifier or not a good pattern recognizer. So it is hard to use as a black box. And that's the message I would like to convey, that industries are jumping on AI in many, and I'll go and show some slides that where we are heading, which is all good and happy, but knowing that it cannot be used as a black box, and many a times in many, like medical field and others, they're complaining the AI methods are not reproducible. And the reason is that there is a lot of parameter tuning involved. So challenges in practice is dealing with unknown, uncertain, unpredictable, and then adversarial manipulation in the system, which can happen during the training, which can happen after deployment. So to avoid data, and this is another thing, algorithm biasness, we require explainable and ethical AI, because algorithmic biasness or data biasness, these are inherent, because most of the AI methods use data, historical data. And if the historical data is biased, then it will learn in a biased way. Sometimes we want biasness of some form, depending on the context. So if you read news in criminal justice system or in race fairness, job market, AI algorithms are choosing a biased decision. And so it is important that they, like in medical field and any other field, AI practitioners have to learn the ethical use. The ethical use of AI is very important, and that if you follow the European Union coming up with guidelines, that it have to, all AI applications have to provide some explainability and make sure it is not biased. And again, the other factor, adversarial. Some people have, whatever their motive is, try to contaminate, do do something fishy about this implementation. How to build trustworthy AI, that is one of the important things. And I'm part of the IEEE task force, which are looking into secure and trustworthy AI methods. So again, like any technical things, the AI has multi-purpose, defensive, offensive, and many other. So how do you make sure that the AI that been used has proper purpose as it's stated? Winning in my presentation earlier, 2020, I referenced here AI versus AI. When two algorithms fight with each other or make it counter decisions, which algorithm will win depend on how much intelligence and flexibility embedded in the system. So even if you look at the IBM winning the chess player or Jeopardy, these are successful because the machine is, competing with human. Human are good at certain aspects, machine are good at other aspects. But when two machines, intelligent machine will compete, whether it's a robot or whether it's something else, who will win depend on how flexible and learnability this algorithm has. So I'm going to show you, these are, you can see in every field now, the AI is being embedded. And the way I see it, it is bound to happen because software now touches in every domain, and you cannot have software which cannot make intelligent decision, and that's where the AI came in. And you can see the starting from gaming to finance to healthcare, transportation, education, e-commerce, entertainment, robotics, automobile, social media, everywhere AI is. And also, US government has taken many initiatives under the DOE research initiative on AI. And you can see that that accelerate the delivery and adoption of AI, then establish a common foundation for scaling AI to impact across DoD. And there are many all other areas you can see AI workforce development, but specific application you can see recently in February 2021, there's called AI Ops that will, the guidelines, if you go through, it is providing that national defense strategy, how AI can be used to different aspects of national, from adversarial domain in every areas. Now I'm moving to my own research, and slowly I'll introduce to the technique that I was going to talk about today on adaptive multi-factor. So my research, if you look at broadly, inner circle is my techniques that I worked on over more than 30 years. Evolutionary computation, immunological computation, neural networks, cellular automata, and then data mining, intelligent agent, but application also in a wide area, outer ring. And if you, these are my citations on my publications, and you can see I have more than 300 publications, 4 books, few edited volumes. I have 7 best paper awards, and you can see H-index, and I was the co-chair of the nature-inspired cyber defense and ACM Sigma. And also I was ACM distinguished speaker and IEEE fellow. These are some of the patents that some already approved, and these are all with my students. And credit also goes to them on working with me in solving these hard problems. Now I'm moving on to some of the things. These are major publications with huge citations of my books. So you can see I'm not a cybersecurity, so-called hardcore cybersecurity. I see that as a problem, and I use my expertise in trying to solve those problems. So when I started in '95, I was working on immune system modeling, and that's my first cybersecurity funding, building agent-based architecture for intrusion detection. And still, what I proposed at that time, still these are valid in defense. For example, you can see the communication need to be collaborative across different modules, the way immune system communicate with B cell, T cell, and antigen presenting cells and other molecules. So co-stimulation is one of the primary things. Our cyber defense doesn't have that. It is coming, and you can see adaptability, because normal definition of normal changes over time. So how to build this mechanism to deal with new normal? When the normal changes or new pattern comes, but the system will be on incremental learning. People are using that, but always the catch is, when do you think the learning ended? Now detection can start. That's the question, a hard question to address. Then on the redundancy side, there are some work has been done on moving target defense, where you move your assets from one position to another so that adversaries cannot target any specific resource. Same is true with the bandwidth, because denial of service and distributed denial of service is a well-known attack type, still happen in every sectors. And then diversity. You have to have diversity in protection and few other aspects that, and this is a separate talk on how to build more robust defense system using some concept of immunology. And there was an article about my research in Computer World magazine on digital immunity. Anybody interested can look into it. So that is one of the area that I invested and still interested. Now I'm moving to my work on the authentication. So you can see user identity becomes more critical, because we are now mostly connected remotely and doing different things. So stealing the identity, whatever that is, now become one of the point for attacker to launch and gain profit. We are hearing that different data breaches, ransomware attacks, and many others, and those are kind of in a daily news. But you can see with this thing, even now in Senate and White House, the discussion is on how to stop these things. So legal liability, government enforcement actions, class actions, and all these are coming. Reputation exposure because of the identity loss and company data stolen, sensitive information leaked, and then typical data breach also cost a lot of aspects like credit monitoring, security technology upgrade. It's a very expensive. So I focused one of the area where the authentication, we can address authentication. And I'm going to show two different approaches that we used over 2009 through till today, and what algorithm we developed. First one was in collaboration with MIT. That was from 2011 to 2013 or 14, called negative authentication system. Again, the concept negative authentication came from immunology. T helper cells can detect only foreign elements, but not body cell. If it detects body cell, then it becomes an autoimmune disease. But ideally, it can only detect the foreign elements. So based on that concept, this IARPA project of $1 million we worked on, and subsequently MIT commercialized it with a company in Canada. So here you can see there are a lot of attempts to access the authentication system. I'm showing an animation to explain what the negative authentication means. Given a positive profile, P, we represent in a representative space, and then which is not in P, we call it anti-password or negative detectors. So we move that in the front layer as a filter, and then this is our security layer 1, and then the security layer 2. That will form a scheme. So you have the password. So someone trying to log in with guessing password, presumably any of those will be activated, so they cannot get into the positive password system. Because what is wrong with having this exposed, there are side channel attacks which can get the password profile stolen, and then that using offline analysis or offline tracking tools, they break the password. Now, having here as a front line, you can filter out those guessing attacks. Of course, it cannot solve the problem. If someone's stolen some password and use it, then it will go through these filters. So it is a two-layer. If someone is trying to use guessing password, then it is supposed to activate one of those things. For example, it didn't activate, then we also have the positive authentication system. So only thing is that the user access or user token doesn't have the direct access to the positive authentication system. So if someone with a legitimate password apply, they will be not, invisible to them that they have gone through this filtering, and they will be checked and access to resources will be allowed. So that is in short how the concept, but we merged that with many other techniques to build our next model. So from this, we found that negative authentication system can detect, and filter out most of the invalid requests, hence lower probability of making guess requests. But again, as I said, offline password cracking it cannot solve. What it can solve is online guessing attacks, which also is a significant using this filter. Exposing the negative detectors upfront reduce the overall password cracking risks. So even if someone stolen the negative detectors because it is refreshed frequently, it is not going to help to attack. So that was the negative authentication. Then we moved to next project, and that was funded by DoD on adaptive multi-factor authentication. Here, and most of you know what is adaptive multi-factor is, and so you can see that instead of only login and password, there are many other aspects are considered to authenticate an user. So, so that is the adaptive. And what we did, not only we added the multiple factors, but we also did some obfuscation. some unpredictability, and that I'm going to talk about in next few slides. Whole idea was that someone wants to connect to a bank or any other resources, any other services through either a desktop, laptop, or mobile device, or using different other ways of communication. So how that person can seamlessly connect over a period of time without logging them out. So we know there are many ways someone can authenticate what the user knows, right? Sometimes it is called cognitive aspects. Some what the user has, like smart card, digital card, or token, driver's license for human identity. And recently, you know, where the user, not even recently, last 5-6 years, what the user is, like GPS location, IP address, MAC address, and any other location-oriented information, or the machine ID, all these are used. And the fourth one, who the user is. Who the user is, that physical biometric, behavioral biometric, all these are now part of the human identity. All of the part of and we used this multiple combination, as I say, geolocation, passwords, SMS, and biometrics, or different kinds of things are there. And we know there are products out there in the market which has different multi-factor authentication products. Microsoft has called Azure, and many others. And the list goes on. So, and this is Microsoft Azure. You can connect from any of those devices. You have to register with different voice, audio, fingerprint, many of those that you want to be recognized as you. And then they put it in the cloud, and when you want to use it, then it will authenticate. So that's and there are number of companies now selling that. Now, what is new in our case that I'm going to show you? In our case, that, providing different choices to user during authentication to verify their identity. That's a good way of doing it. However, all factors may not be available in all operating conditions. And it comes with fail safety in case any authentication factor get compromised. Question is, how do you choose a better set of authentication factors out of all possible choices in a given operating environment? That's the question we wanted to address. And also we wanted to make sure that the choice that been provided are not fixed. So if anybody monitoring your login authentication pattern, they cannot predict next time what is coming. Now, there are nowadays like different security questions, but that also has a limited scope. You may have 3 security questions, and it rotates one or the other. But in our approach, the framework can allow n number of possibilities, and that n can be 100, 200, whatever that is. So that's where the advantage is. So there are many ways you can make this multi-factor. One is static. Most of the companies now do this, a predefined set of modalities for any given environment. Or you can make it dynamic. Dynamic can have 2 different options, random or adaptive. And we selected the adaptive. And you will see the reason for selecting adaptive. So now we all know the biometrics are widely used, but there are many ways biometric can be what you call the spoofed. With the movie industries, the mask or face mask or skin, artificial skin, someone can change their face recognition can fail. And there was few years back, there was a attack in Brazilian bank where the attacker where the mask, which appears to be one of the customers, and they were automatically gone through the security check. Same as biometrics are good up to a certain extent. Its accuracy varies from 60% to 99%, depending on many factors. Again, another question is, we are many times we are in a public place with shared Wi-Fi or connections. So there also we need some kind of protection to where the information is going through wireless, and you may need to check more frequently who the user is, and is the same user who has logged in and currently using. Then we also have wide variety of apps which sometimes behave not in a way that you expect. So user apps also need to be monitored for access to sensitive information. Here is a scenario I'm showing what we looked into. Again, I want to make sure, can you hear me? Yes?
Yes, we can hear you.
Yes, we can hear you.
Okay, here is a scenario. Suppose there are multiple face recognition, fingerprint, voice recognition, SMS or passphrase, SMS, and the list can go on. I'm showing in 5 situations, and now it is 8 o'clock. You can see. So it is a noisy environment because I'm playing music. So voice recognition will not be used. It is a dark. Suppose I'm a coffee shop or in a place where the illumination is low, then face recognition and related will not be used. So the method will sense the environment and the way user is connected, the type of device user is using. So again, when these two are, then here voice and low light, so that will not be, those two will not be used. But in addition to that, many other passive authentications will be used. If situation is a noisy, low light environment, then those two will not be selected. So we designed and implemented a robust, scalable framework for multi-factor authentication. Selection of multiple authentication factors are conducted adaptively considering the operating device. What kind of device it is using, the user is using. Connected media, where wireless or cellular or Wi-Fi or Bluetooth, whatever it is, and the surrounding condition, noise, noisy, low light. So considering all these things, this is the overall conceptual view. So you have these type of modalities like keystroke, voice, fingerprint, SMS, captcha, login password, and face recognition. So, and depending on, and we tested on our the what do you call we have online courses. We tested with 30 users on this online courses during that. So our contribution is this adaptive selection of multiple factors. So effect of different devices, effect of different media, and each of those has some trustworthy levels, and we calculated their calculation on that, and the effect of different surroundings. Like in a trustworthy, wired connection is considered more trusted than wireless, and there are some measurements on that. So based on that, what these modalities will be selected, presented to the user. Sometimes they are active, sometimes they are passive, and each of the modalities are placed in a backend server, maybe in a single server or in multiple servers or in cloud, and they will be pulled for authentication. So I'll see if this link works, so that I'll play this short video. Let me see if my time permits. And this is we represented it as a multi-objective optimization with the error minimization, then checking the environment and cost effectiveness. So that's a and that provided kind of using genetic algorithm time varying selection. So depending on 1 to 3 different factors are selected at triggering time. Triggering time, maybe you are logged in for a long period of time, or you are logged in and moved from one media connection to another one, still you are connected. So various triggering time. Not used previous predefined policies. So if you are selected with one, checked with one, it will not be checked with others. The same in next time. So guided random authentication selection. And so this is how they illustrate. So which activity will now the time has elapsed. So you decided every 2 hours I should be checked whether I'm the same person who logged in. So this time it is checking with CAPTCHA and password. Next time the device, you change the device from wired device, you are connected with the laptop, then your face recognition. So some may be active, some may be passive, the media change. So it is part of called continuous authentication, which is now become more and more used in industry. So it goes in a 3 different mode of operation. I described is a normal mode with a specific events. It triggers. When it goes something fishy, maybe continuously passive authentications are being selected because of the environmental situation, then it can go in a vigilant mode. When the operating environment suggests not to select some active modalities. So more passive and standby authentication factors need to be considered, then it goes in a vigilant mode. So what that means, they watch the user carefully. And if that continues for again for some time, then it goes in a surveillance mode. When the adaptive multi-factor runs in vigilant mode for a long time, then the authentication system goes into high alert mode and activates other monitoring systems in the network, intrusion detection system or firewall or something. So as I said, there is a video. There's a company called Okta. They are selling their product with our names, adaptive multi-factor, and you can find it. So the key features of this, you can see that it can provide continuous identity protection. We also call it auth spectra, is always on, ensuring the user's identity as long as they were connected to the system or service. It makes a just-in-time decision. That's where the power comes in. There's nothing stored that the hackers can exploit. When the triggering happens, then the genetic algorithm in the back end, it will run and push to the outside user. Now the user have to be authenticated with this. So optimal decision, and it uses this machine learning techniques to find out which is the best optimal, and we use the optimization, and which is the multi-objective, and we consider the Pareto optimality again. It is, I'm going a little bit deeper on that. And then it is any new modalities, passive or active, you can add on to this. So that's the another advantage. then you can see it can have wide variety of applications. Some applications people started doing it. I'm going to show next. And this is the team who works with me on this development, and all of them are in a very good positions now working in different companies. So these are some applications, continuous high confidence identity authentication for banking, including online fund transfer, online testing of an education training, secure access to electronic medical record, and you can deploy it at a different level, application level, like when you get the payslip, it should not have only your last name and last 4 digits of social security number. It can change anything adaptively. Then you can have it as a user level. So the root user will have stronger authentication, administrator or guest user, all it can be at the document level. So that was the first version. In version 2, we extended it to 21 different modalities taking from different sources, and that was our version 2. And there are continuous improvements are possible. If anybody wants to take that as a research component, like mobile devices has now so many sensors. You can see accelerator, gyroscope, all can be indicator of some identity, location, orientation, and that can be used as identifying the object. Nowadays, not only the human identification, you can also, in an IoT environment, you can identify, is there the same IoT, same medical device or the sensor is sending data to me, the doctor, or somebody spoofing or someone else. So I think I'm done with my time. There are different adaptation levels you can go. And again, there was a nice article following our research came from Belgium. They indicated that adaptation can be done at a multiple level, at a different places. So you make it obfuscated to the hacker in different ways. I'm going to stop here and look for any questions.
Okay, thank you so much now for the very good and insightful presentation. So the floor is open for people on the cyberspace to ask questions. We have sometimes for folks to ask questions. Any
Yes,
questions?
I can take questions.
Yes. Any question from cyberspace?
This is John. One of the biggest threats that I see is the man-in-the-middle attack.
Right.
And I think that because there is a not predetermined number of authentication steps, that I think this can be used to thwart the man-in-the-middle attack, because even if you capture the first or even the second set of credentials, you don't know how many of those you need to capture before the user is authenticated. So I think this is a really good solution to that problem. And this is an especially prevalent problem for the V2X infrastructure. As we look at these things are stable, they can be lurked on, they can be broken into, because you can capture data over a long period of time and reverse engineer the authentication keys.
I agree. And that's one of the following our work, and there are many directions people are taking it, and man in the middle attack, because there is nothing predefined, and it is a just-in-time decision, and decision will be pushed from secure side to the user, whether it's a mobile device or something, or their own laptop, desktop. So even someone steal the information in once, but they cannot do for all the things.
So have you looked at the decision-making engine that decides when to elevate the level of authentication required based on some behavior or some statistics.
So I showed you there are three mode of operations, and we only tested two mode of operations because, you know, this kind of work need a huge funding source, and some companies, as I said, Okta is using our name, but they never disclosed how their adaptive system works. There are now it has, and we have a patent. There is a company who licensed it. It can go in a many direction, and as I said, in our small pilot study with 30 people, we tested up to the second mode, that it is in vigilant mode, because surveillance mode require activating intrusion detection system, firewall rule change. All that's a part of the defense in depth.
Thank you so much. With your permission, I'll follow up independently after this meeting.
Yes, yes, and as I said, this is the how the world is moving now. When you are in a computer, and I borrowed from NIST. If you are in a computer, you have a lot of trail of information. Your semantic, the way you write the text, all can be used in our model to authenticate, you know, as frequently as you want. It need not have to be all active authentication. Do this. Majority of the things can be done in a passive authentication, I think, which is commercially viable. And then if there is some triggering occurs, then you can go on active authentication, take your biometric or do something the user. Otherwise, without disturbing the user, seamlessly user's identity and credential can be verified.
Thank you, sir.
You are welcome.
Great, thank you. Okay, any other question from the cyberspace? Come on, guys.
So in terms of collecting data for each type of like interaction, I guess like in terms of both physical and like visual, is there like use like the same type of like machine learning model for each one? So like neural networks for each one, or something different?
Can you repeat the question?
Sorry. So in terms of, you mentioned that there's like multiple ways that you in terms of like the visualization, like when you talk about voice recognition, fingerprints, stuff like that, does it all use the same type of machine learning model for each one, or is it like different types of models they use?
We used, see, our machine learning model is to determine which authentication need to be used. So, but we have used three different voice recognition software. So, and if you, this is the video, YouTube, you can find it in YouTube.
Hello, everyone. The University of Memphis Center for Information Assurance research team has developed a novel multi-factor authentication prototype. The Adaptive Multi-Factor Authentication Framework identifies authorized users through an active authentication process using passwords, biometrics, cognitive behaviors, and other factors. Authentication factors are selected adaptively by sensing the user's operating environment. This includes connected devices, communication media, and surrounding conditions. Previously selected one-time passwords are supported through the use of mobile devices. The client application captures the ambient light, noise, and location to determine the user's surrounding conditions. The network information is used to determine the type of device being used, fixed or portable, and the connection type, be it Ethernet, Wi-Fi, or cellular. This information is used to differentiate between multiple connections of the same user. All of the information collected is passed to the server over a secure encrypted connection. The server will process the information and return a response directly to the client. If the SMS modality is chosen, the server sends a password to the user's registered mobile device. For the time-based one-time password, a secret is shared with the client during registration. After this point, no communication is required to be made with the phone in order to use one-time password. As a part of user statistics, each connection request is logged in the database. Raw biometric data sent by the user must pass through a feature extraction phase. The relevant features are collected and stored in a template. Only templates, never raw biometric data, are stored in the database. Authentication modalities. Selected modalities are returned as a challenge to the user. After the user responds to the authentication challenge, the features are extracted from the responding biometric data. These features are matched against the target features, which are retrieved from the database. Based on the match result, the server will successfully authenticate the user or...
I'm not going to play the whole video. So this is how the system is built. So we use the voice recognition, fingerprint, all these are which are available. Some were commercial, some were open source. So 3 different voice recognition methods, 3 different fingerprint techniques. So we had variations even in each modalities also. So giving and when it comes to because we collected the vectors of the face, so sometimes we matched only the eye portion. Sometimes we match only the mouth portion. So you don't have to match the whole face because there are other factors of checking in. So this video is available in YouTube. You can do it, adaptive multi-factor authentication. You can find it. I'd like to see if there is any other question or if I answered your question correctly.
Oh, you answered my question. Thank you for the explanation, sir.
Thank you.
Okay, we have time for one more question.
Hello, Doctor. Thank you for your presentation. I'm Rabbi. I have a quick question about the technical details of your authentication approach. In your authentication approach, have you used any type of encryptions or basic coding and path management to identify the cyber challenges?
So did I use any encryption
or patch management approach or blockchain so that you can identify a vast number of features whether there is any cyber threat or not? Have you gone through in this approach?
So authentication can be added during communication of the information. Encryption can be added, but those are, extra layer of security. That was not the part of this research. Part of the research was to find the best modality, authentication modality, given a certain condition. And condition is how the user is connected, what's the media, what kind of device, and what's the environment that is appropriate. But storing those signatures in a server in an encrypted way, communicating with the client in an encrypted, these are can be added irrespective of this method.
Okay, thank you for your explanation.
Okay, well, let's thank the speaker one more time. Thank you so much. It was really a great presentation. Given that today is Friday before the long holiday,
yeah,
over 35 participants.